postulate, little excellent postulate here. If two angles form a linear pair, then they are supplementary. So let's see. Remember what a linear pair is? A linear pair is when you have kind of this like a straight line, a straight angle, if you want to think of it that way. And then there is a ray coming out, so I have two adjacent angles, right? That is going to be a linear pair. Yeah?
Does the ray have to be at the midpoint?
No. And again, no, it does not. To be a linear pair, it does not have to be equal. And this is a line going like forever. So it doesn't even, does it have a midpoint? That's a good question. So anyway, angle 1 and angle 2 form a linear pair, so angle 1 and 2 are supplementary. So what is the measure of angle 1 plus the measure of angle 2? 180. So that's the little fill in the blank on the bottom of page 2. That makes sense. That one I hope is obvious. Of course, you'd be surprised. This comes up a lot in our first linear pair postulate. If you find a linear pair, you're supplementary. So let's look at this one. This is the right angle congruence theorem. And this says, all right angles are congruent. Now this could be a postulate, right? Is it kind of obvious? But if we can prove it, we do prove it. So let's prove it. So I'm given two right angles here, right? So here's my given. I'm on the top of page 3. Hopefully we're following along, copying it down. So since they're right angles, I'm now stating that the measure of angle 1 is 90 and the measure of angle 2 is 90. How come I can say that? How come I can say that? Absolutely, the definition of right angles. Whoops. I can't remember how I did this. Definition of right angles. I thought I had this. Oh, there it is. Okay. The measure of angle 1 equals the measure of angle 2. All right, now, some of you are having trouble seeing this one. I'm looking for somebody who's having a little trouble with this. How much you know what the reason is? Anybody? Yeah, why? Oh, are they the same? Reflexive is with the angle 1, angle 1. So it can't be reflexive. Look at the one above, and then look at what's happening here. What do you think, Maria? Is it transitive? She's asking very tentatively. Well, why do you think it's transitive? They both equal 90. You can almost read it backwards. If A equals B, and B equals C, and A equals C. This looks like transitivity to me. Transitive property of equality. And again, I'm writing of equality. These are not congruents that I'm looking at. I'm looking at comparing equals. Okay, now where did I want to go with this? What should my last statement be? Yeah.
Angle 1 and angle 2.
Yeah, how'd I get there?
Definition of angle congruence theorem.
Right? So that was pretty easy. It should be pretty easy. It's kind of an obvious statement. But now I can do that. So if you ever have two right angles or three right angles, you can say they are congruent. Why? Because all right angles are congruent. Now let me just say one thing. Some people like to really memorize those names. The right angle congruence theorem. For some of them, I think it is easier, like the segment addition postulate. It's easier to remember the name than the whole statement. For me personally, I am not real good at remembering these names. But I will remember that all right angles are congruent. So if you need this in a proof, I will take either way. If you write right angle congruence theorem, that's fine. If you can't remember titles of theorems, but you can remember the gist of it, all right angles are congruent, that's where you go. Because this is not like, a universal name. This is not what everybody calls it, but everybody knows this. So if for some cases, I think it may be better just remembering what the theorem is. So we'll look at that a little bit later. Now, congruent supplements. This is a kind of an interesting little one. If two angles are supplementary to the same angle or to congruent angles, then they are congruent, meaning these two angles that you're starting with. So let's look at the picture. And I don't think I have the picture on your chart, so if you want to draw that in there in your notes. So let's see, angle 1 and 2, we're given that they are supplements. Angle 3 and 2 are also supplements. What can I conclude that 1 and 3 are congruent? Yeah. There is some kind of transitive idea here, and I think you're noticing, you're seeing the 2 and the 3, and so 1 and 3, there's going to be a relationship. But we're not saying they're supplementary. I guess that might be like a pure transitivity. But we're saying they're congruent. But you're seeing, she's really kind of looking at them now. You're getting that analytic eye, which is terrific. So here's my givens. Oh, let's see. Given. Okay, so I'm just mentioning that two of the angles, who's supplementary to whom. So now what am I saying? They're supplements, so the measure of angle 1 plus the measure of angle 2 is 180, and the measure of angle 3 plus the measure of angle 2 is 180. How come? Definition of supplementary angles. Absolutely. That's what it means. Anybody see where we might be going next? Even though I don't want to, I'm not looking at the paper. What do you think's coming next? I think. Why can we do that? They're both equal to 180. So what's our reason? Transitivity then. Transitive property of equality. This one equals that one equals that one. So these two must also be equal. They're equal to the same thing. Oh, do we see what's happening? Can we see without peeking at the notes? Look at this. And look where we want to go. Well, look what I got going here. What can I do? Yeah, let's subtract out the measure of angle 2 by subtraction property of equality, right? That says you can subtract the same thing from both sides of the equation. We're nearly there, right? Angle 1 congruent to angle 3? Definition of congruent angles, or angle congruent, that's fine. So look at that. So if you know these two angles are both supplementary to this guy, then they are going to be congruent angles. That's kind of cool. That comes in handy sometimes. So this one could be a little bit tricky. I like your idea of kind of looking at that I see that they're supplementary to the same thing. It's almost like looking for transitivity. Almost like that, but they're going to be congruent. Now, we also have congruent complements. It's the same idea. What do complementary angles add up to? Yes? 90. So it's the same idea, except now my angles look more like 90-degree angles if I were to add them. Angle 1 and 2, these are complementary. They add up to 90. 1 and 3 also add up to 90. So what can I conclude? These are angle 1, right? Same thing. So it's 2 and 3 that are going to be my congruent angles. So let's start with our givens. And this is pretty much the same proof. Except now, instead of adding up to 90, I'm adding up to 180. So same reason now, definition of complementary angles before we were looking at supplementary. I'm going to set them equal because of the transitive property of equality. They're equal to the same thing. I can see this measure of angle 1 in both of them, so I can subtract that out to get the measure of angle 2 congruent to the measure of angle 3 using that subtraction property of equality. If their measures are equal, then the angles themselves are congruent by the definition of a congruence theorem. So it's the same proof, but so now I have congruent supplements, congruent complements. This might be one of the theorems, or these two might be easier to remember the title, congruent supplements, congruent complements. Or you can write this out. Depends what you want to do if you need it. So we'll follow these. Okay, good. So let's see, we have some here that we're going to maybe apply it a little bit. Now we've talked about vertical angles before. Remember what vertical angles are? What's a vertical angle? Yeah, we kind of said, okay, if you have like two intersecting lines, if they're kind of across from each other, those are vertical angles, they're always congruent. And we just kind of accepted that, but we shouldn't have. We said, well, why can I say that? I have to prove that. So we're going to prove it now. Vertical angles are congruent. So I've got a picture here. This one is in your notes here. Angle 1 and 3 are vertical angles. It's given, but it's also kind of a definition. That's what vertical angles are. So I can say what's given. Prove that they are congruent. So I know they're vertical. Prove that they're congruent. So let's see where we're going here with this one. Now I'm going to go look at something a little bit differently. I'm going to say angle 1 and 2 are a linear pair, and angle 2 and 3 are a linear pair. So 1 and 2, these are a linear pair. 2 and 3 are also a linear pair. Do we see that? You get what a linear pair is, right? Here's this line, the line coming out. These two things are a linear pair, and those two things. Now, why can I say that? Because that's what they are. You're allowed to say, the diagram shows us that. Remember those things we're allowed to assume, the things we're not allowed to assume? If it looks like a linear pair, if it looks like a straight line, we can say that's a linear pair. So now where am I going with that? Because as they're a linear pair, they are supplementary. Oh, who says we could do that? That's just brand new. On page 2, yeah? The linear pair postulate says that if you have a linear pair, they're supplementary. Oh, it's easy. Okay, Look what it's saying here. 1 and 2 are supplementary, 2 and 3 are supplementary. What can we conclude? 1 and 3 are, look up there. This is the same one we just had, yeah. 1 and 3 are congruent. Look over at your Congruent Supplements Theorem. What does it say? Look right on the paper there. Congruent supplements, it's in that upper right corner. If you have 1 and 2 are supplements and 3 and 2 are supplements, meaning they're supplementary to the same thing, then these things are congruent. It's a little bit like transitivity, but not quite. Right? Right? They're congruent. So we're already using that theorem. Now we can, with authority, use and prove vertical angles are congruent. We didn't do that before because we hadn't proven it. Let's see what else we got. Look at our summary now. Look at all these things. The linear pair postulate. If 2 angles form a linear pair, then they're supplementary. This is not on the notes, but remember, this is posted. So if this is a nice, helpful chart, you can get this from the website. Right angle congruence theorem, all right angles are congruent. Congruent supplements theorem. If 2 angles are supplementary to the same angle or to congruent angles, then they're congruent. Similarly, congruent complements, same thing, but with complementary angles, and vertical angles are congruent. All right, so we want to keep those, in the forefront. We've got our notes to kind of look back at them if we need to, but we can solve problems based on that. So let's see. Find the angles and what postulate theorems are used. So measure of angle 1 is 112. I got them off my diagram. Can't do it otherwise. Find the measure of 2, 3, and 4. 2, 3, and 4. How do I do it? And then we're just going to talk about what postulates and theorems we use. But how do we do it? Yeah, what do you do?
Because of the vertical angle congruence theorem, 3 is 112.
Yeah. Because vertical angles are congruent, so we've used that one. This is one that I always write out. Vertical angles are congruent. I'm not good at remembering. So that's one theorem we're using. What else can we use to find the other angles? Yeah? How are we using that? These form a linear pair, therefore they are supplementary by what? Linear pair postulate? So I can say they're supplementary. So then what's this one? What's that one? 68? So I think that's all I needed was the linear pair postulate. I could probably have used congruent supplements. I could have gotten there somewhere, but it's making it harder. Now what's the last one? That's also 68. I could have used either reason. I could have gone because they're vertical, or I could have gone, I can see a linear pairs. They're going to be supplementary by the linear pair postulate. So now stuff we've been kind of doing, we've been doing this already, but now we have reasons for it. Okay. So now each one of these is like a brand new problem. So this no longer applies. So if the measure of angle 2 is 67 degrees, then what are the other angles? What are they? Come on. Yes, sir.
Angle 4 is 70.
By what reason? Vertical angles are congruent, yeah. And then what else? What about angle 1 or angle 3? Angle 1. The linear pair postulate says they're supplementary, so, how did I figure it out? 1 over 13, right? And then I can either use that same postulate again, or I can go to vertical angles, right? Do the last one yourself. Tell me what you get. 2. Here, run back. And angle 1 and 2 are complementary. Angle 2 and 3 are complementary. Angle 1 and 4 are complementary. Do we have any congruent angles here? Look at this funny little thing. Right, so what do I know? These two are complementary. These two are complementary. And these two are complementary. Yes, sir.
Is there a way to label that?
I don't know how to label complementary. There must be. I don't know what it is. We have to look that up. But I'm kind of looking back here, and it's kind of popping at me. It's a little bit like that transitivity thing. So Kelly, what do you think? What can I conclude just from the statement alone? Are they all congruent? Go look back at your congruent supplements theorem. Keisha, what do you think? Angle 1 what? Or what? No. Go back, read the theorem, Yes.
Angle 1 and 3 are zero.
They're congruent because of the congruent complements theorem. That states if you're complementary to the same angle, 3 is complementary to 2 and 1 is complementary to 2, they are congruent, not complementary. Yeah.
I thought angle 4 and angle 3 are also congruent.
Why?
Because 4 is complementary to 1, 1 is complementary to 2, and 2 is complementary to 3.
All right, so say it again.
4 is congruent.
4 is complementary to 1, 1 is complementary to 2, 2 is complementary to 3. Or you can even use substitution and say, well, angle 1 and angle 2 are complementary. So that means 2 and 4 are congruent? Is that where you're going?
Yeah, 4 and 3.
Okay. I'm going to hear first, because then that helped me do exactly what you said. 4 and 3? So we're kind of like chasing them around a little bit. Wow, that's pretty good. I think I got them. I got myself all turned around now. 4 and 3. Why 4 and 3? Yes, you're right. Absolutely, yes. Angle 8 congruent to angle 6 because vertical angles are congruent. What about these two? And those are for the vertical angles. Pretty good. So there's lots of stuff here, lots of ways to find them. Yeah, what else? Say it again. How is angle 4 congruent to angle 2?
Complementary to 1, complementary to 2, complementary to 3.
The angle 1 is complementary to angle 4, right? Angle, say it again.
Then 1 is complementary to 2.
So that gives us these two being congruent. All right, what else?
Then 2 is complementary to 3.
Complementary to angle 3. So let's think for a second here. I know these are equal, right? We're congruent. So that means I could replace this with 4. And so now I'm seeing 1 and 3. That's this one. I got back to where I was. I think you're right. I'm having trouble getting there. But wow, so there's a lot of different things we can find out. There's a lot of different stuff. What? Yeah, it is. All right, let's see. Can we do example 3? How do we find the values of variables? This one you can do on your own, but tell me, how do we do that? How do you do this one? We could use that. The only problem is, I could, but now I'm going to get a system, right? I've got 3x plus 7 equals 7y, and 5y plus 28, like this. Want to do something like that? Now it looks like I got to solve like 2 minutes. I mean, it could. What might be an easier way? Yeah, when I see these kind of problems, I'm like, what's going to give me problems with one variable? So that's easy to solve, and this one's also easy to solve. Okay, am I right? Those are easy to solve? Equations, one variable each. So that might be the easier way. When you go through these and you find the angle measures, I always check. Whatever you get for x, plug it in here, make sure they're the same, that you didn't make some math mistake. Whatever you get for y, plug it in here, make sure they're the same. I'm going to just leave this one for a moment because I want to get to the proofs. So I want to give you some time to do other things today. Okay, so now I've got this proof. STU is 50. What am I proving? This angle, angle S, is the same as STU, this whole thing. Okay, that's where I'm headed. So I'm starting it. Angle S is a right angle. How come? Okay. Something equals the measure of RTS and RTU. Something is. RTS, RTU. What's that going to be? The measure of angle STU. Yeah. And how come? The angle addition postulate. Okay. What the measure of angle STU, now what we're going for here, sometimes I think these fill-ins are a little hard. What is the measure of angle RTS? Because I know I'm using a substitution here. What is it? It's 40 degrees. And what's the measure of RTU? 50 degrees. So how do I simplify that? I have to add them. And then I'm saying it's a right angle. Because, why? That's what a right angle is. It's 90 degrees. And now once it's a right angle, what can I say? Yeah? Right. The right angle congruence theorem, or you can just say, all right angles are congruent. To me, that's a little easier to remember. It would be easier for me to remember that than something called the right angle congruence theorem. So there you go. That's not so bad. Or is it? Number 5. Oh, picnic table. The figure shows the side view of a picnic table. Angle 1 congruent to angle 4. Prove that 2 is congruent to 3. So in your minds, can we prove that? So we kind of see what's going on. What is congruent to 4 is my given. Angle 1 and which angle are a linear pair? Which one? Angle 2. And angle 3 and angle what are a linear pair? 4. Why? That's what a linear pair is. Right? You can see it in the diagram. So now what? My reason they're giving me is the linear pair postulate. So where am I going next? Yeah, where am I going?
Angle 1
Yeah. Because they're supplementary, right? Now, should we have put another statement in here saying they're supplementary? Technically, that is the linear pair postulate. This is okay. Supplementary and equaling 180 are kind of the same thing. And so now it's just going straight there. It's going angle 2 congruent to angle 4. Angle 3. How do you think they're so quickly? Well, you can say this, or let's do this. They're supplementary. I think that might actually work out better. We can see it. Because if this is supplementary and that's supplementary, and what else do I know is true? 1 and 4 are the same thing. I'll put a measure of angle 1. I feel like they left out a statement here. I'm going to put in another statement. I'm going to call it 3A. Measure of angle 3 and angle 1 are supplementary. And that's by substitution. So look at that, 1 and 2 and 3 and 1. So 2 and 3 are supplementary to the same angle. Therefore, they are congruent by congruent supplements. Oh, a little bit messy. They left out a couple of statements. Congruent supplements here. They needed a 3A in there. All right. I think we fixed it. We fixed it. This is a U-try. The U-try, definitely do this one. This one, there were some mistakes on the notes. So that second U-try, it's kind of okay. It's kind of okay. When you get to the end, this one, measure of angle 2 equals 90. believe that should be the statement. So kind of move this over, the measure of angle 2 plus the measure of angle 4 equals 180, and you've got to figure out why. And angle 2 and angle 4 are supplementary, that's my conclusion. And you have to figure out why. So there were some mistakes in the notes section there. So if you want to try and correct that, maybe we can try and figure